Good afternoon, ladies and gentlemen. I am Artur Mugatarov, a first-year postgraduate student of the Perm National Research Polytechnic University. Also, I am a research engineer in the Center of Experimental Mechanics. The topic of this work is influence of loading conditions on GFRP fatigue sensitivity curves parameters and transition to critical states. This work is devoted to the problem of mathematical description of fatigue damage accumulation regularities and composite mechanical properties reduction under various loading conditions and reinforcement schemes. Decrease of mechanical properties during cyclic loading is a theme which was investigated by many scientists. There are many papers published, but there were many experimental works. Here you can see typical diagrams of tensile strength reduction and damage value for various preliminary cyclic exposure. Previously, authors of this work proposed to plot fatigue sensitivity curves on the left side in the coordinates of preliminary cyclic exposure and small versus fatigue sensitivity coefficient KB, which can be calculated this formula. Three characteristic stages can be defined on the diagram. The first of them, called initiation stage, and third, called aggravation stage, are characterized by fast mechanical properties reduction and high value of accumulated defects. The second one, the stabilization stage, is characterized by it takes place when fatigue coefficient decrease slowly and damage accumulation rate is also low. We propose to divide this curve on these three stages using the points S1 and S2, where damage accumulation rate is equal to 0.3. But such division is conditional and may vary depending on the material and its class, and it can be equal to some parameter delta. Here shown some approximate formulas of fatigue sensitivity curves. The first one is based on two-parameter Weibull law of probability distribution. The second is based on beta distribution. The third model was proposed by Mao and Mahadeva. The first pair of models requires definition of two parameters. It's lambda and kappa, or alpha and beta, and these models was proposed by us. Last model requires three parameters definition. Each of parameters, of course, in general case, depends on loading conditions, temperature, stress state of material, etc. Previously obtained fatigue sensitivity curve was approximated using these three models. You can see fatigue sensitivity curve and damage accumulation rate curve on this slide. The model which was proposed by Mao and Mahadevan has the best fit to the experimental data. However, it shows very slow mechanical properties decrease on the aggravation stage, and it seems to be implausible. The beta distribution and the Weibull law-based model are very similar, so all the other experimental data was approximated using only Weibull law-based model. First, we investigated maximum stress value during the cycle influence. GFRP specimens were tested under various maximum normal stress values equal to 0.4, 0.5, and 0.6. Fatigue sensitivity curve and damage accumulation rate curves were plotted. The dependencies of the model parameters on the maximum stress value during the cycle are nonlinear and non-monotonic, and we can see that low value of stresses led to fast reduction of mechanical properties on the initiation stage, but it makes stabilization stage long, and damage accumulation rate is very low. Then we investigated temperature influence, and room temperature and under 120 degrees temperature. High influence of the temperature on the fatigue sensitivity was found out. High temperature during tests led to longer duration of the stabilization curve and late completion of this stage with the low damage accumulation rate. The last fatigue sensitivity curves parameters also depends on reinforcement scheme of the composite. It was discovered that ±45 scheme, this one, the red line, has long stabilization stage and low strength decrease. It means that cross-reinforced glass fiber reinforced plastic shear strength isn't sensitive to preliminary cyclic loading at all. Here are some conclusions of the work. Experimental data of the GFRP strength decrease under various loading conditions and reinforcement schemes was obtained. Approximation of experimental data using various models was carried out. The significant influence of the loading conditions on composite reinforcement scheme on the fatigue sensitivity and the damage accumulation rate curves was revealed. And we plan further modification of these models for the usage under various loading conditions. Thank you very much for your attention. I'm ready to answer your questions.